All right, here we go. So today we're going to talk about solving compound inequalities. So let's talk about what that word compound means. If you think about a compound sentence, it would be two sentences put into one. So that's what a compound inequality is. It's going to be two inequalities put into one. So we're going to look at that today. Make sure you fill in all the notes, and then you'll show your notes to the sub, and you'll be able to get your homework. All right, here we go. So we've got compound inequality, two inequalities joined by the word and or the word or. Those are going to be two really important words as we go through this. So let's talk about the word and. The graph of a compound inequality with and is the intersection of the graphs of the inequalities. So you're going to be thinking about the intersection of these two graphs. So where are the graphs? If you were to put them on top of each other, where do they overlap? Okay, so you may even want, instead of intersection, you may want to write the word overlap, because that's what you're going to be looking for here. Okay, so if you look at this first graph, you see x is greater than negative 2. So we have this graph here, everything greater than negative 2. On the second line, we have everything less than or equal to 1. And if we were to put these graphs on top of each other, the only place that they would overlap would be from negative 2 to 1. Okay, so it satisfies both inequalities. Okay, so that's the word and. If you think about or, the word or means it could be one or the other, which means it could be either. So if we look at x is greater than or equal to 0, then we look at x is less than 1, it could be one or it could be the other. So we're going to have both on the number line. Okay, so what we're going to do is we're going to translate the verbal phrase into an inequality, and then we're going to graph the inequality. And remember, we're going to be looking for those two words, either and, or we're going to look for or. All right, so we've got all real numbers that are greater than or equal to negative 2 and less than 2. When you see all real numbers here, that just means we're going to have a variable. Okay, so we have all real numbers, so let's just use x. So x is greater than or equal to negative 2, and I want to write that word because that's going to be important, and less than 2. Okay, well, what's less than 2? Okay, well, that's just saying that the all real numbers are also less than 2. So we have x is less than 2. All right, so think about that word and. Okay, and I'm going to graph both of these on the same number line. I'm going to graph one above and one below, and then on the number line, I'm going to graph my final answer. Okay, so I have x is greater than or equal to negative 2. So I'm going to throw a negative 2 and a 2 on here. Make sure those are in the right order. All right, so everything greater than or equal to negative 2. So that's going to be a closed circle, and I need everything greater than that. And then I have x is less than 2, so that's going to be an open circle, and then everything less than that. Okay, so since we want and, we want to see where these two lines overlap. And they would overlap from negative 2 to 2, and everywhere in between. Okay, make sure you keep the closed circle on the negative 2 and the open circle on 2, because that's important. Okay, let's look at B. All real numbers that are less than or equal to 3 or greater than 6. All right, so we've got all real numbers, so that's x, that are less than or equal to 3, or they're greater than 6. Well, what's greater than 6? It's those all real numbers. So we've got x is greater than 6. Okay, so I'm going to go to my number line. I'm going to throw my 3 and my 6 on here. I'm going to do the same thing. I'm going to graph one above and I'm going to graph one below, and then on the number line I'm going to graph my final answer. Okay, so I have x is less than or equal to 3. So I have a closed circle, and I need everything less than that. Or I have an open circle on 6, and I need everything greater than that. Okay, so since this is or, this can be one or it can be the other. So I'm going to have everything less than 3, less than or equal to 3, and also everything greater than 6. So that's what my final answer would look like. C, all real numbers that are greater than negative 8, so x is greater than negative 8, and less than or equal to negative 3. So all my real numbers are less than or equal to negative 3. So look, we're looking at an and, so we're going to be looking for where these overlap. Okay, so I'm going to put my negative 8 and my negative 3 on here. Make sure those are in the right order. So I need everything greater than negative 8, and I need everything less than or equal to negative 3. And we're looking for where these two would overlap if we put them on top of each other, and they overlap from negative 8 to positive 3. Okay. All right, so this is solving a compound inequality with and. So notice that this is all written as one big compound inequality, and it's sharing this stuff in the middle, the 3x minus 3. That's part of both inequalities. Okay, so if you wanted to, you could break this into 2. Okay, I'm going to show you what I mean, but I don't want you to solve it this way. I just want to show you that this could be broken into 2. Okay, so if we started with the 3x minus 3, it would be 3x minus 3 is less than 24. If we read it back going the other way, so going back that way, it'd be 3x minus 3 is greater than 15. So we have two different inequalities here. You could solve these both separately, but that would kind of be a waste of time because there is a shortcut here. All right, so since this is sharing the stuff in the middle, we can go ahead and solve this like we would solve a normal equation. Okay, so I need to get x by itself. How do I do that? I need to get rid of the minus 3 first. Okay, so we're going to add 3. But the thing is, if you add 3, you also have to do it to the other side. Well, there's two other sides here. So I have to add 3 to the 15. I also have to add 3 to the 24. Just like you're solving a normal equation, it's just there's two equations put into one here. All right, so now I have 15 plus 3 is 18, is less than 3x is less than 27. Now we're still trying to get x by itself, so how do we get the 3 off? Okay, we're going to get the 3 off by dividing by 3, but you have to do it everywhere. Okay, once we do that, 18 divided by 3 is 6, is less than x is less than 9. Okay, now since this is an and problem, I do know that these are going to be overlapping, or they should be. But if you want to break this compound inequality into 2 when you graph it, it might help you not make an error when you graph. So I'm going to break it into 2 so you know what I'm saying here. So we have x is less than 9. If you read it going back the other way, you would have x is greater than 6. And that's going to make it a little bit easier to graph. So I'm going to throw the 6 and the 9 on my graph. Okay, I'm going to graph one above and one below, and then I'll graph my final answer. Okay, that's just so I don't mess it up. So I have x is everything less than 9, and then I have x is everything greater than 6. And my answer is going to be where these two overlap, which would be everything from 6 to 9. So that's my final answer. You won't be graded on the one above and the one below. You'll be graded on your final answer. So if you have another way of getting that final answer right, then do it. This is just the way that I think is the easiest way to work it. All right, let's do another one. Okay, now I know that this is going to be an and because it's sharing the stuff in the middle. Okay, it's both of them. It's and. It's overlapping in the middle. Okay, so I can do a shortcut here. I need to solve for x, so I'm going to subtract 1 from everywhere. So 15 minus 1 is 14, is less than negative 7x, is less than 49. All right, now we still need to solve for x, so I'm going to divide by negative 7. Okay, now here we need to remember our rule for the other day. Remember, when you multiply or divide both sides by a negative, you have to flip the sign. Well, we're dividing everything by a negative here, so I need to flip both of those signs. So I'll have negative 2, and then that's going to flip to greater than x, and that's going to flip to is greater than negative 7. Okay, now we need to graph these, and I just think it's easier to break this apart and then graph it on the number line. So we would have x is greater than negative 7, and if I read this backwards, it would be x is less than 2. So I'm going to throw negative 7 and 2 on my number line. So I have everything greater than negative 7, and I have everything less than 2. And the area that they overlap is everything from negative 7 to 2. Okay, and if you get stuck somewhere, y'all, just pause the video and catch up. If you need to rewind, do that, or just keep moving on, whatever is best for you. Okay, we're not going to waste the time to do this. It's just more practice problems for y'all. And actually, yeah, we're not going to do these because y'all can rewind and rewatch it if you didn't get it the first time. But I'll have the full filled-in notes on my website if you want to go back and look at these. Okay, now let's look at this. This is a compound inequality, but with OR. Notice that this is two completely separate inequalities. It's not like the last ones where it was shared. There's two completely different ones separated by the word OR. So we have to solve these both separately. Okay, so I have 5x plus 6 is less than negative 9. I'm going to subtract 6. So I have 5x is less than negative 15. I'm going to divide both sides by 5. So I get x is less than negative 3. We're not going to flip the sign. Okay, and then over here I'm going to add 8. I have 2x is greater than 20. Divide both sides by 2, and I get x is greater than 10. All right, I'm going to throw my negative 3 and 10 on the number line. And this should be going opposite ways since it's an OR. Okay, but I'm going to go ahead and graph it above and below just to make sure, because we're going to see some special cases here in a little bit. Okay, so I have everything less than negative 3, and I have everything greater than 10. So since this is an OR statement, that means it can be one or the other. So I'm going to put them both on my number line. There we go. Okay, again, we're going to skip this, okay, because I'd rather just teach you the material and not wait for you to practice these problems. Okay, now we're going to look at writing the inequality and then solving it. Solving and graphing. All right, so we have 2 times x is less than or equal to negative 4, and it's greater than negative 20. So we have 2 times x, so that's 2x, is less than or equal to negative 4, and it's greater than negative 20. So 2x is also greater than negative 20. Now we cannot graph these yet because x isn't by itself. So I'm going to divide by 2, and I will get x is less than or equal to negative 2. And then I'll divide by 2 on this other inequality, and I'll get x is greater than negative 10. Okay, so I'm going to throw both of those numbers on my number line. Okay, notice this is an AND statement, so we're going to be looking for where these two overlap. So I have everything less than or equal to negative 2, and I have everything greater than negative 10, and the area that they overlap It's everything from -10 to 2. Everything in the middle. All right, number 2. And then we may skip number 3. Number 2, 3 less than x is less than -1, or 1 more than x is greater than or equal to 8. Now notice that we have 2 different places where you see less than. Okay, we kind of talked about this in the notes last time, but one of those less thans is going to be mean minus. Okay, so we have 3 less than x. Okay, so that's the one that means minus. Remember less than, those are turnaround words, so you're actually going to write this in the opposite way that you read it. So instead of 3 minus x, it's actually x minus 3 is less than -1. Or, and I'm going to write that so I don't forget, or 1 more than x, so 1 plus x, is greater than or equal to 8. Okay, so we're going to solve these so we can graph them. We're going to add 3 to both sides. That gives me x is less than 2, or I'm going to subtract 1, so x is greater than or equal to 7. Okay, I'm going to throw my 2 and 7 on my number line. And I have everything less than 2. And I have everything greater than or equal to 7. And this is an or statement, which means it could be one or it could be the other, which means I'm going to put both on my number line. Okay, we're going to skip 3 just for time's sake, but it is filled in on my website if you want it. All right, now we're going to look at some special cases. All right, you'll see why these are special here in a sec. So we have 2x minus 1 is greater than 3, or 3x plus 5 is greater than or equal to -4. Okay, so let's just start working these out like normal. So we have 2x is greater than 4. I'm going to divide both sides by 2, and that gives me x is greater than 2. Then over here I'm going to subtract 5. So I have 3x is greater than or equal to -9. I'm going to divide by 3. So x is greater than or equal to -3. All right, so let's put these on our number line and see what happens. I'm going to use that top number line to graph one above and one below, and then we'll use that second number line to graph our final answer. Okay, so I'm going to have -3 and 2. Okay, I have x is greater than 2. So I have an open circle and everything greater. And then I have a closed circle on -3, and I have everything greater than that. So notice that our lines are going the same direction. We haven't had one like that yet. Okay? Now, since we're talking about an or statement, this could be one or it could be the other. We're not looking for where they overlap. It could be one or the other. It could be either one. Okay? So our final answer is just going to be the long one, because it could be one or the other. So I don't need to graph both. I can just graph the long one. I know that's probably a little bit confusing, but hopefully it'll start to make sense. All right, number 2. Now notice this is an and. So we're going to add 8 to both sides. I have 3x is less than 15. We're going to divide both sides by 3. And we get x is less than 5. And then over here, we're going to subtract 7. And we get x is less than -4. Okay, so I'm going to throw both of those numbers on my number line. Notice that this is an and statement, so we're going to be looking for where these overlap. That's what we're going to be looking for. Okay, so I need everything less than 5, and I need everything less than -4. Okay, now one more time, this is an and statement, so we're looking for where they overlap. The only place that these two overlap is from -4 and to the left. So everything from -4 and on is the only place these overlap. So notice why these are special cases. They're special because they're different than all these other ones. Okay, they're going in the same direction. Right? We're gonna skip these, but if you don't understand these special cases, go back and watch the last two that I just did again. Actually, let's pick one of these to do. How about we'll do, let's do number 3. I want to make sure y'all have enough examples. So number 3, I'm going to subtract 6. Notice this is an and. That leaves me with -x is less than or equal to -2. Now I don't want to solve -x, I want to solve for x. So we need to divide by -1. But what are we doing here? We're dividing both sides by a negative, which means we need to flip the sign. So I have x is greater than or equal to 2. Okay, and then over here, I'm going to subtract 9. So I have 4x is less than -12. Divide both sides by 4. And I get x is less than -3. Okay, so I'm going to throw -3 and 2 on my number line. I have everything greater than 2, and I also have everything greater than -3. Okay, now since we're talking about an and, we're looking for where these overlap. Okay, and the only place, if you put these on top of each other, the only place they overlap is everything greater than 2. So that orange line is my final answer. Okay, we're going to skip number 4. All right, so I'm going to draw on here what these special cases would look like, just so you have a summary of all these. Okay, so for and, we could have graphs that look like this. We didn't see an example like that on an and. That's what our ors looked like, but not on our and. And remember, for and, we're looking for where they overlap. And do these two lines ever overlap? No. So our answer here would be no solution. There's nowhere where they overlap. Okay? Then we have the example that we just saw. Okay? We have a long graph. Then we have a short graph. Okay? And we're looking for where they overlap, which would only be from here to there. Okay, now with or, there's a couple of different ways you could see special cases. Remember, with or, it could be one or the other. It could be either. Okay, so I could have a graph that looks like this, which we saw when we talked about and. When we talk about or and we see this, if it could be one or the other, it could be everything. So here our answer would be all real numbers, because these overlap everywhere, from negative infinity to positive infinity. Okay, then we could see an example like we saw before, where they're both going the same direction. But since it could be one or it could be the other, it could be the whole long graph. Okay, so make sure you understand those. You won't see a lot of those on the test. There may just be a couple, but you definitely need to know how to do that. Okay, so these are just a couple of practice problems. If you want to stop the video and work through them and maybe check with the person next to you to make sure you have the right answer, that might be a good option. Make sure all these notes are filled in, show them to the sub, and you can get your homework. And there should be examples like all of these on the homework. It should be on the notes. So definitely work together if you don't understand. And there's something else I was going to tell y'all. Well, I don't remember what it was. Okay, so So just make sure you get that done, and I will take up this homework next time. Oh, make sure you do the homework. Make sure you show all of your work. Do not just pick an answer choice. Just make sure you show all of your work on every single problem.